Automatic kernel cleanup sounds sensible, until the kernel you expected to use for a rollback is the one that disappears. Linux Mint is reworking how kernel management works. The project says the feature is moving out of Update Manager and into the System Administration tool. More importantly, it is shifting the focus from individual kernel builds to kernel series. You choose which series to follow, decide how many older kernels to keep, and the system can remove older unprotected kernels on a weekly schedule. That may sound like a simple tidying feature. For people who only ever run the latest standard kernel, it probably will be. But for anyone who has ever needed to boot an earlier kernel after a driver issue, a regression, or a hardware problem, the real question is not, can Mint delete old kernels? The real question is, which kernel is safe to let go and which one needs to stay? That question gets more important when you are not on a plain standard setup. Maybe you use hardware enablement kernels. Maybe an OEM kernel came with a laptop. Maybe you have a real-time or custom series for a specific workload. Mint's own update is careful here. The tool can identify unfamiliar series, but it does not magically take responsibility for them. So this is not a generic Mint news recap. We are going to separate what is already available, what Mint says is planned, and what you should verify before you trust an automatic cleanup schedule. We will look at the shift to series tracking, how protection changes the rollback story, why custom kernel series deserve extra caution, and finish with a practical pre-cleanup checklist. By the end, you should know whether this feature will simplify your maintenance or whether it needs a little more thought before you turn it loose on a machine you rely on. And there is one detail in the official wording that matters more than it first appears. Mint is not only deciding what to remove, it is redefining what counts as a kernel you are actively following. That is where the story really starts. Before we get into cleanup rules, we need to separate two things that are easy to blur together. Linux Mint says there are new 22.3 HWEISOs available with kernel 7.0. That is a real current availability statement. Hardware enablement media exists to give new installations a newer kernel baseline, which can matter for recent graphics, wireless, storage, and laptop hardware. The kernel management changes are a different part of the same update. Mint explicitly frames the features and improvements in this monthly news post as work in progress and a preview of what is planned for the next release. That wording is important. It means this video is not telling every current Mint user to expect a new weekly cleanup behavior on their machine today. It is explaining the model Mint has described, so you know what to look for and what questions to ask when it arrives in your workflow. That distinction is where technical videos often go wrong. A new ISO, a development update, and a future feature can all appear in the same post. If we treat them as one finished release, viewers can make changes based on the wrong assumption. For this story, the useful question is not, should I install kernel 7.0 immediately? That depends on your hardware, support requirements, release track, and your own testing. The useful question is, when Mint's new management model is present on the systems you support, what choices will it make easier, and where does it still require you to think like the person responsible for the rollback path? The answer starts with a design decision that sounds subtle, but changes how you read the whole tool. Mint is moving away from presenting kernel maintenance as a pile of individual version numbers. Instead, it wants you to think in terms of a series you are deliberately tracking. If that sounds like a small interface redesign, hold on to the rollback question from the start. Because once the unit of management changes from a build to a series, the safest thing to keep is not always obvious from a long list of version numbers. Most people encounter kernel management as a list. You see a version number, maybe a few older versions below it, and the question becomes, which one do I click? Mint's planned model changes the first question. Instead of starting with individual builds, it starts with a series. In the project's wording, you choose which series you want to track. The tool then manages the relationship between that chosen series, its meta packages, and the regular updates that belong to it. Why does that matter? Because a kernel is not just a file you install once and forget. It is part of an update path. If you are following a normal supported series, you want the system to keep receiving the correct updates for that series without making you hunt through every individual build. For a standard setup, that can make maintenance less fragile. You decide what you are following, you set how much history you want to keep, and the management model has a clearer idea of which older builds are simply old history rather than part of an active plan. But there is a reason we keep coming back to the word decide. The tool is not reading your mind. It does not know that one older kernel is the version you kept because a specific Wi-Fi driver, graphics stack, or USB controller behaved better on it. It knows whether a series is tracked. It knows whether an individual kernel is protected. The practical job is still yours. Decide whether the fallback you care about is actually protected by the choices you made. This is also a useful reminder that latest and safest are not synonyms. On many machines, the current supported kernel is exactly what you want. On a machine with unusual hardware, a production workload, or a recent regression, the best support posture may include a known good fallback. The series model can make the normal path easier to maintain. The protection model is what keeps a deliberate exception from being cleaned up as clutter. And now we can look at the part people are likely to notice first. What Mint says will happen when older kernels enter the cleanup queue. Here is the behavior that will get the most attention. Mint says older kernels can be automatically removed on a weekly basis. That sentence is useful, but it is incomplete if you stop there. The update describes a model in which you choose the series you want to track and decide how many older kernels you want to keep. That means cleanup is not meant to be a blind instruction to delete everything except the newest build. It is part of a retention policy. For a normal desktop system, that can be exactly the right direction. Older kernels can accumulate over months. They take space, make boot menus noisier, and turn a simple support question into a long list of numbers. A sensible retention count gives you a little rollback history without treating every old kernel as permanent inventory. Mint also describes two practical controls. First, you can trigger cleanup manually if you need space now, rather than waiting for the weekly schedule. Second, the tool offers a history view, so you can see which kernels were removed and when. That history matters more than it sounds. When a user calls with a problem after an update, one of the first support questions is often, "What changed?" A cleanup record gives you at least one visible part of that answer. It does not replace documentation, a proper change log, or testing. But it is much better than discovering that an old kernel is gone and having no idea when the removal happened. Now for the tension in this design. A retention count is only safe if it matches your actual recovery needs. If you keep one old kernel, but the last two updates introduce different problems, one may not be enough. If you have a machine that depends on a particular known good version while you investigate a hardware issue, relying on a general retention rule can be too casual. This is where Mint's protection feature becomes the important safety valve. The project says an individually protected kernel becomes immune to cleanup. That turns a passive retention preference into an explicit decision. This one stays until I decide otherwise. And that is the difference between automatic cleanup and automatic cleanup with a rollback plan. A protected kernel is the line between "I hope this older version stays around" and "I have deliberately kept this as a fallback." Linux Mint says that when an individual kernel is marked as protected, it becomes immune to kernel cleanups and is never deleted by that cleanup process. That is the key practical rule in the whole update. If you have a laptop that had a graphics regression after a recent update, the working fallback is not clutter. If a particular wireless chipset works reliably on one known good build, that build is not clutter. If you are supporting a machine remotely and you have not yet proved that the newer series behaves correctly in that environment, a retained fallback can be the difference between a calm recovery and a much longer repair. That does not mean every machine needs a museum of old kernels. Keeping every kernel forever defeats the point of maintenance. It uses space, complicates the boot path, and can make it harder to see what is actually current. The aim is a short, intentional recovery path. A good question to ask is, if the current kernel fails in a way that affects my work, what would I boot next? If you cannot name a sensible answer, you should not assume an automatic retention count happens to cover you. Look at what you actually need to retain. For a straightforward desktop, that may be one previous supported kernel. For a system attached to unusual hardware, a production workload, or an ongoing compatibility issue, you may want a more deliberate plan. The answer is not a universal number. It depends on how often you update, how easy it is to physically access the machine, what hardware is involved, and whether recovery is a minor inconvenience or a serious outage. This protection feature also solves the first open question from the start of the video. No, Mint's cleanup model is not meant to make you powerless over a needed fallback, but it only protects what you explicitly protect. That is why the next part matters. The standard tracked path is one thing. OEM, real-time, and custom series are another. The standard tracked series story is reassuring. The non-standard series story is where you need to slow down. Mint says that if you install a kernel from an unknown or custom series, the tool can list that series and give you the option to mark it as tracked. But it also says that in the case of a custom series, the tool does not know how to install the correct meta packages and warns that it is your responsibility to do so. That is exactly the right level of caution. A tool can tell you that a kernel exists. It can help you decide whether to keep it, but it cannot automatically understand why you installed an OEM kernel, a real-time kernel, or a custom build in the first place. It does not know whether that series is tied to a vendor requirement, a specific low-latency workload, an out-of-tree driver, or a problem you are still diagnosing. This does not make the feature dangerous. It makes the boundary clear. Automatic maintenance works best when the system understands the update path. The moment you step outside that path, you need to verify the basics yourself. Where updates come from, how the series is tracked, whether the fallback is protected, and whether cleanup could remove something you still need. For administrators, this is also a configuration management question. If a fleet has a standard supported kernel series, the new model may simplify the local maintenance story. If a fleet mixes OEM images, custom drivers, real-time workloads, or one-off hardware exceptions, a local graphical tool is not a replacement for documentation and a tested recovery plan. There is another subtle point. Mint says that if a series is not tracked, all of its installed kernels are removed in the next cleanup unless they are protected. That makes tracked and protected different tools for different jobs. Tracking is about the series you intend to maintain. Protection is about a particular kernel you do not want cleanup to touch. That distinction answers the second open loop. On a non-standard series, do not assume the new tool has solved the maintenance problem for you. It has made the responsibility more visible. And with that in mind, we can turn all of this into a practical workflow rather than a collection of warnings. At this point, the practical decision is simpler than the technical wording makes it sound. Before you rely on a cleanup rule, identify 4 things. First, which kernel series are you intentionally following? Second, which kernel would you use if the current one caused a problem? Third, do you have an OEM, real-time, or custom series that falls outside the simple supported path? And fourth, have you tested the recovery route you are assuming will be there? If you can answer those questions, the new model becomes easier to use. You can let ordinary old builds be cleaned up without feeling like you are gambling with the machine. You have a defined series for normal updates, a protected fallback where you need one, and a clear list of exceptions that deserve more attention. If you cannot answer them, that is useful too. It tells you not to turn a maintenance feature into an automatic decision yet. The correct next step may be as simple as documenting the current kernel and keeping a known good fallback while you test the new path. By the way, I checked the current channel analytics while preparing this video. About asterisk 83% asterisk of the people watching tondoeslinux and more are not subscribed yet. If these practical Linux deep dives help you avoid a bad support decision or save time on a real machine, subscribing is the best free way to support the channel and make sure the next one reaches you. The next point is worth making because it protects viewers from a different kind of mistake. A clean kernel management screen, a new HWE-ISO, or a weekly cleanup option can look like proof that every part of the support story is solved. It is not. It tells you that Mint is building a more deliberate way to manage the normal kernel lifecycle. It does not prove that every driver, boot path, client machine, or unusual workload has been tested. Knowing that boundary is not pessimism. It is exactly what turns a useful update into a reliable workflow. The most responsible way to read this update is also the most useful one. Mint has described a clearer kernel maintenance model. That does not mean every kernel question is settled. The official post tells us what the project is working on. It tells us that management is moving into system administration, that it is based on tracked series, that old unprotected kernels can be cleaned weekly, that cleanup can be triggered manually, that history is available, and that protected kernels are exempt. Those are concrete statements. What the post does not give us is a universal benchmark. It does not say every hardware combination will behave perfectly on every new kernel. It does not say a retained fallback is guaranteed to solve every regression. It does not replace testing an actual laptop, desktop, or support image in the environment where it matters. That matters because kernel maintenance is one of those topics where confidence can become dangerous very quickly. A user might hear automatic cleanup and assume the tool has selected the perfect number of fallbacks. An administrator might hear series tracking and assume it has covered every exception in a mixed fleet. A reviewer might see a new HWE and treat it as evidence that the entire management model is already finished everywhere. None of those are fair conclusions. The better conclusion is that Mint is trying to make the normal path easier to understand. That has real value. Clearer retention, visible cleanup history, protected exceptions, and a direct place to manage series are all improvements in how a user can reason about a kernel lifecycle. But a tool that makes decisions visible still needs someone to make the right decisions. That is especially true when the machine is hard to access, when a driver issue is expensive to diagnose, or when a support team needs a predictable recovery story. This is the point where a news item becomes a support habit. You do not need to fear automated cleanup. You need to know what it will clean, what it will preserve, and what it expects you to protect. With the boundary clear, we can finish by turning the source material into a short pre-cleanup checklist that works whether you are managing one desktop or a small group of systems. Here is the practical checklist I would use before trusting a new cleanup policy on a machine that matters. Start by identifying the kernel you are running now. Not because you need to memorize version numbers, but because you need to know what the current working baseline is. Then identify the fallback you would actually use if that baseline stopped working after an update. Next, decide whether that fallback is just one of several older kernels or whether it is important enough to protect. If it is the kernel you expect to rely on after a graphics, wireless, storage, or hardware regression, treat it as a deliberate exception. Do not leave it in the same bucket as old builds you only kept by accident. Then look at the series you intend to track. On a normal supported setup, that should be straightforward. On a machine with an OEM, real-time or custom series, pause and verify how that series receives updates and whether you have explicitly marked it for tracking. Mint's own update says responsibility stays with you for custom series, and that is the part not to skip. After that, decide on the retention count. There is no magic number that fits every system. A local desktop you can reach easily has different recovery needs from a machine you support remotely, or a laptop with hardware that has already been through a driver regression. Retain enough history for the recovery path you can actually use, not simply the smallest number that saves a little disk space. Finally, test the recovery assumption while you still have time to fix it. If your plan is to boot a fallback, confirm that you know how you would select it and that the fallback is genuinely present. If your plan is to rebuild a custom series, make sure the source, packages, and documentation are available before cleanup turns an easy option into a longer repair. That last step is the one people skip because it does not feel exciting, but it is the difference between reading an update and operating a system responsibly. With that checklist, the new Mint approach makes much more sense. It is not asking you to choose between manual maintenance and blind automation. It is trying to give you a more intentional normal path, provided you keep ownership of the exceptions. So, is Linux Mint's new kernel cleanup model a good idea? Yes, if you read it as a management model, not a promise that every kernel decision can be automated away. Mint is moving kernel management into system administration and focusing on the series you deliberately track. It is adding a clearer way to decide how much older kernel history you want, clean it up on a schedule or manually, inspect the cleanup history, and protect an individual kernel from removal. That is a meaningful improvement because it turns a long, messy list of old builds into a maintenance conversation. What are you following? What do you need as a fallback? And what is safe to remove? But the update does not remove the need for judgment. A standard tracked series is one thing. An OEM, real-time, or custom series is another. A local desktop with easy recovery is one thing. A remote support machine or unusual hardware setup is another. The safest way to use this feature is not to fear cleanup. It is to decide your rollback path before cleanup runs. Know the current baseline. Keep the fallback that matters. Protect it when it is an exception. And verify that the series you depend on is being maintained in the way you think it is. That is the practical takeaway. Linux Mint is making routine kernel maintenance easier to reason about. It is not taking responsibility away from the person who understands the machine, the hardware, and the recovery cost. If you run Mint or LMDE, I would like to know how you handle rollback kernels today. Do you keep a fixed fallback? Do you protect specific builds? Or do you rely on the normal update path and test when something changes? Leave your setup in the comments. If this breakdown helped, like the video and subscribe to tondoeslinux and more for practical Linux news and support-focused deep dives. And if you want to support the channel directly and get some cool perks, consider clicking the join button below to become a pseudo user or get root access.